Projectiles, type 3, angle of projection. So in this question here, we have a particle is projected with a velocity at an angle beta to the horizontal ground. So if we draw our horizontal ground, we have our particle is projected at an angle beta with respect to the horizontal. So we have to show that the particle hits the ground at a distance u squared over g sine beta from the point of projection. And we also have to find the angle of projection, which gives maximum range. So maximum range is important there. Okay, so again, we're going to start with looking at making out our table, knowing also when we're doing this question, because we're looking at maximum range, then we're going to be using the fact that Sy is equal to 0 on landing, given that this is our range, S in the x direction. So again, if you pause the video and see, can you make out your table yourself? So we're not told anything about u here, or beta, so therefore u in the x direction is just going to be u cos beta, and u in the y direction is u sine beta. Still on the horizontal plane, so our acceleration due to gravity is still 0. We have no gravity in the x direction because gravity acts in the y direction. It's projected in an upward direction, therefore we're taking that as our positive direction, and therefore g being downwards will be given a negative sign, so minus g. V is equal to u plus at, so we have v in the x direction is u cos beta. V in the y direction is equal to u sine beta minus gt. S equals ut plus a half at squared. So in the x direction we have S is equal to u cos beta. And in the y direction we have u sine beta minus, u cos beta t and u sine beta t minus a half g t squared, given that the time is in terms of t. So the first thing is to show that it hits the ground from the point of projection. So the distance from the point of projection is basically another way of saying find the range. So we know the range is when S of y is equal to 0. So the first part of the question is the range when Sy equals 0 on landing. So Sy is equal to u sine beta t minus a half gt squared. So if I let that equal to 0, I multiply across by 2. Then if I take out t as being common, that leaves me with 2u sine beta minus gt. And if both of those factors multiply to give me 0, that means that one of them or both of them must be 0. So we have t is equal to 0, or 2u sine beta minus gt equals 0, and therefore t is equal to 2u sine beta divided by g. So obviously t is equal to 0 at the start, and therefore t equals 2u sine beta over g is our time of flight. So the time that it takes to get from the start point to the end point. So now we know our time of flight, we can easily work out our range, because we know our range is S of x when t is equal to 2u sine beta over g. And we know that our S of x is equal to u cos beta t. So if I sub in my time, and I have 2u sine beta over g, which gives me 2u squared sine beta cos beta all over g. But we should spot there that we have 2 sine beta cos beta. And of course we know in trig on page 14 of our tables that that is equal to sine 2 beta. So obviously in your maths tables it's going to say sine 2a is equal to 2 sine a cos a. So you're just adapting the a to beta here. And therefore that becomes s of x is equal to u squared sine 2 beta all over g, which is what they wanted you to show. Okay, so if we go back to the start of the question, it says, show the particle hits the ground at a distance u squared over g times sine 2 beta, which we've just done. And now we have to find the angle of projection which gives maximum range. Now maximum range, if I'm looking at s of x there, well, we just had shown that s of x is equal to u squared over g sine 2 beta. So for that to be a maximum range, well, the maximum range can only occur when the angle is at its greatest. In other words, when sine 2 beta is equal to 1. Now, if we think about trig in maths for the moment, well, a sine graph is a periodic graph where its period is 2 pi. And the range is 1 and minus 1. So in other words, if I go beyond 1 or minus 1 there, I get undefined because my graph cannot lie outside that for my function y equals sine a. So if I have the function y equals sine 2 beta, well, of course, again, the range here is still going to be 1 and minus 1 because the coefficient of sine there is 1. And of course, then the period of that graph would be pi rather than 2 pi. But this maximum value here is 2 beta because outside of 1 it's undefined. So therefore that tells me that 2 beta is equal to sine inverse of 1, and sine inverse of 1 is 90 degrees, and therefore beta must equal 45 degrees. So in other words, the maximum value we can have for the angle to get the maximum range is when the angle of projection is 45 degrees.